Hello there. Let's talk about type conversion in Java. Let's start off by understanding the definition of type conversion. So, type conversion refers to the conversion of a value from one data type to another compatible data type. And it happens during assignment or in expressions. Now, the definition looks pretty simple, and it actually is, but there are a few nuances around type conversions that we would need to understand. And this is what this video is about. But before I get started with more details related to type conversion, I would like to draw your attention to this part. This says that it is conversion of a value from one data type to another compatible data type. Now, leaving all of this aside, if we focus just on this, it tells us that type conversion involves data type. So let's recap and talk a little about data types in Java. Now, data types in Java can be categorized into two broad categories, and they are primitive data types and non-primitive data types. Primitive can be categorized in four subcategories: integer, floating point, character, and boolean. And each of these subcategory has got some data types that Java supports. For example, integer has got byte, short, int, and long. Floating point has got float and double. Character has got char, and boolean has got boolean. Then we also have non-primitive data types, which includes class, interface, array, etc. This video will focus on primitive data types in Java, which means we will not talk about non-primitive data types at all. But having said that, I should also mention that a similar concept exists for non-primitive data types, and they are upcasting and downcasting. Now, like I said, we will not talk about non-primitive data types, which also means we will not talk about upcasting and downcasting in this video. With this clear, let's go back to the definition of type conversion and let's take a look at few examples where type conversion will take place. The first example is this: byte A is equal to 100. Now, what's happening over here is we have a variable A of type byte to which 100 is getting assigned. Now, over here, we have got 100, and 100 is a literal. And more specifically, 100 is an integer literal. Now, by default, integer literals in Java are of int data type. So what's happening over here is we are assigning 100, which is of int data type, to a variable A, which is of byte data type. Similarly, in the next statement, we are assigning whatever is stored in A to B. Now, A over here is of byte data type and B is of int data type. So in the first example, it was int getting assigned to byte, and in the second example, it is byte getting assigned to int. And since one data type is getting converted into another data type, type conversion is taking place. So coming back to the third example, over here we have got A multiplied with 50. Now we know that A is of byte type and we are multiplying this with 50. 50 again is an integer literal like 100 over here. And we know that integer literal will be int type by default. So what are we doing over here is we are multiplying A, which is of byte type, with 50, which is of int type. So in this multiplication as well, which means in evaluating this expression, type conversion will take place. Now, this will result in some value, let's say v, and this v will be of certain type. It will be int, but I'll discuss the reason later. So v is of int type, and this is getting stored in C, and C is also of int type. So in all of these examples, some kind of type conversion is taking place. And that is what the definition of type conversion says. It says that it is conversion of a value from one data type, like we saw from byte to int or int to byte, to another compatible data type. Also, it happens during assignment or in expressions. So it's happening over here during assignment, and it's happening over here during the evaluation of this expression. So we have understood everything that is there in this definition except this part. That is, it is conversion of a value from one data type to another compatible data type. And we will discuss this as well, but not right now, in some time. Right now, let me ask you a question. if you take a look here, you can see that there are a total of 8 primitive types. Now, if I ask you a question that if we have 8 primitive data types, what will be the number of pairs that we can get, considering that we have got 8 primitive data types and also considering that the pair can have the same element? What will your answer be? Well, the answer is pretty simple. It will be 64. But let me tell you, how did I reach 64? So we want to find the number of pairs, right? Which means we need to take two data types. So I have got two places to hold the data type. Now, for the first place, I've got 8 options, right? Because I've got 8 data types in total. For the second place as well, I've got 8 options. Why? Because I said that the pair can have same data types, which means that if I choose byte for the first one, I can choose byte for the second one as well. So the reason for getting 8 over here is the same as getting 8 over here, because we've got 8 options to choose from for each of these positions. And that gives us a total of 64 pairs. Now, if I take these 64 pairs and if I lay them in a table, this is what it will look like, right? And each of these cell over here will represent one pair, right? For example, this cell represents long, long. Similarly, this one represents int char, and this one represents char int. Another important thing over here is that type conversion is the conversion of a value from one data type to another compatible data type, which means type conversion will take place when there are two data types involved, say D1 and D2. And it also says that it is conversion of a value from one data type to another compatible data type. So it means that both of the data types should be different. And that means if D1, for example, is byte, D2 cannot be byte, because then type conversion won't take place. So what does this tell us? This tells us that out of the total 64 pairs that we have, there will be 8 such pairs where there will be no type conversion, right? And those 8 pairs will be byte byte, short short, int int, long long, and so on for all of the data types that we have. So let's go to our table and let's mark all of those pairs where type conversion won't take place with a hyphen. So we will mark byte byte with hyphen. We'll do the same for short, int, long, float, double, char, and boolean. Now, another important point to discuss over here is if I have got two data types, say D1 and D2, the more commonly used names for this will be source and destination, where source is the data type which is getting converted and destination is the data type to which source is getting converted. Going by the definition over here, this is referring to the source data type and this is referring to the destination data type. Now, with this clear, let's come back over here. Now here, we just discussed that there are a total of 8 pairs where there will be no conversion. That is, the conversion won't take place. And we marked all of those 8 pairs with a hyphen in this table. But there are also some pairs where the conversion is not possible. Let's talk about those pairs. So we know that there are a total of 8 primitive data types, right? And out of those 8 primitive data types, we have got 7 which can hold numeric values. And the only one which cannot hold numeric value is boolean, and it stores either true or false. Now we also know that in Java, there is no way in which you can map true or false to a number, or you can map a number to true or false, which means that if we have, for example, 100 stored in a byte variable, we cannot convert that to boolean, right? Similarly, if we have got a boolean, we cannot convert the value that is there, be it true or false, to byte. And that means that the 14 pair that you can see over here, that is byte boolean and short boolean, long boolean, boolean short and boolean double and so on, are the pairs where the conversion is not even possible. So let's mark these 14 pairs with a cross in the table. And those pairs are boolean byte, boolean short, and also So out of the 64 pairs that we started off with, we have got 8 where the conversion won't take place, because conversion takes place when the data types are different. And we have got 14 where the conversion is not possible. And it is not possible because boolean holds non-numeric values and all the other 7 data types holds numeric values. And if we come back to the definition of type conversion over here, this is what compatible means. So coming back to this table, over here we are left with 64 minus 8 minus 14 is equal to 42 pairs. So the 42 pairs that we are left with are the ones where conversion will take place. So let's talk about these 42 pairs. Now, these 42 pairs can be categorized into 2 categories. One, where the conversion takes place automatically, and this is called automatic type conversion. Now, automatic type conversion happens when the 2 data types are compatible and the destination type is larger than the source type. So let's understand what these two means. And once you have a good understanding of what these two means, you'll be able to identify which of those 42 pairs will undergo automatic type conversion and which one won't. Now, in order to understand these 2 points, we will have to take a look at data types, their width, and their range. Now, when we take a look at the data types along with their range, let's ignore width for now. We can observe a few things. The first observation is that Boolean is non-numeric, right? That is, it holds true or false, and it cannot be mapped to a number or it cannot be converted to a number. And all the other 7 data types are numeric. Now, if we take a look at these 7 data types, that is the ones which are numeric, we can draw a few more conclusions. Char is numeric, right? But it can only hold positive integers. And it can hold positive integers up to a certain number, but we will come to it later. Now, if we take a look at long, int, short, and byte, what can we observe? We can observe that these are numeric, which means they can hold numbers and they can hold both positive integers and negative integers, right? Now, if we take a look at double and float, what can we observe? Well, they are numeric, of course. That means they can hold numbers, but what kind of numbers? They can hold decimal numbers, right? Now, if we take a look at this entirely, what can we observe? We've got 4 categories. The first one is non-numeric. Then we have a category which is numeric and can hold only positive integer. Then we have another category which is numeric and can hold both positive and negative integers. And lastly, we have a category which is numeric and can hold decimals. Now, let's talk about the first point over here. The first point says that automatic type conversion will take place when 2 data types are compatible. So let's talk about compatibility among these 8 data types. Now tell me, is Boolean compatible with any of these 7 data types that we have? No, right? We have established this already. So Boolean has got compatibility with none of the data types. Now let's come to char, which is the only data type in the numeric plus positive integer category. So if I talk about char, it is numeric plus it can only hold positive integers up to a certain number. Now take a look at the range this time. The range is 0 to 65,535, and take any random number which is between 0 and 65,535 and tell me which of these remaining 6 data types will char be compatible with. Now, when I say compatible, it means that whatever value is there in the char variable can be converted to a different data type. Now, let us assume that we have got 65,535 in a char variable. Now, char variable can hold that value, right? But can I hold that value in a byte variable? No, right? Because the value is 65,535, but the maximum value that byte can hold is 127. Now, the same question, but for short this time. Can I hold 65,535 in a short variable? No, because of the same reason, and that is the maximum value that short can hold is 32,767, which is less than the value that I have in the char variable. Now, can I hold 65,535 in int? Yes, because the maximum value that int can hold is way larger than what I have in the char variable. And the same thing applies to long, right? So this means that char is compatible with int and long. Now, let's talk about char having 65,535 and see if we can store that in float or double. Well, you tell me, if you have 65,535, or let's say you have a smaller number, say you have 100, can you store it in a float variable or a double variable? Well, if you know, great. If not, please open IntelliJ and please write a small program along with me just to verify this. So over here, I already have a class with the name type conversion and typecasting, which has got a main method. Inside this, what am I going to do is this. I'm going to say char c is equal to, let's take a small number, 100. And next, what I'm going to do is I'm going to say float f is equal to c, and I put a semicolon to end the statement, and we see there are no errors. Let's do something similar, but with a double variable this time, and we will say double d is equal to c. Again, no errors. Now, what will we get if I print the values of c, f, and d? If I run the code, what do I get is D as the first line of output, which I'll explain why in a minute. But the second line of output gives us 100.0, and the third line of output also gives us 100.0. So let's talk about the second and the third line of output first. So what we have done over here is we had C, which is of char type and which had 100 stored in it. And we stored that 100 in a float variable. Now we know that float holds decimal number. And because of how float represents decimal numbers internally, the 100 that we stored got converted to 100.0, and that is what we're getting as an output. The same logic applies to the third line of output being 100.0, where what we did was we printed D, where D is a variable of double type and it holds whatever C holds, and C holds 100, right? Now coming back to the output that we got, the first line of output is D and we stored 100, but why are we getting D? Well, it is because when you store an integer in a char variable, what happens is it internally gets converted to the character that it is mapped with, and 100 is mapped with D. Now, I'm assuming that you know ASCII and you're able to understand what's going on over here. If not, I have discussed about ASCII briefly in one of the videos, and the link to that video is popping up right now on the top right corner of your screen. So if you want to understand what ASCII is, please check that video out. Now, coming back to this, what did we conclude from this? We concluded that we can store a positive number without any decimal point in float and double. And what's going to happen when we do that? Well, it internally gets stored with a .0. So coming back here, we can say for sure now that char with a range of 0 to 65,535 can be stored in float or double, because the range of float and double is way more than the maximum value of char. So considering this, let's update this list. So we're done with boolean and we're done with char. Now, these two data types belong to a category where they were the only data types in that category. Now let's talk about the third category that we have, which is numeric plus positive plus negative. That is all those data types which can hold numbers, and they can hold both positive and negative integers. And over here, let us start off with byte. Now, if we take byte into consideration, it has got a range of -128 to 127. Now, if I have a byte variable which holds a number, can I convert that to char? Well, no, because that byte variable can also have a negative number. And char, as we know, can only hold positive number, right? So this establishes the fact that byte and char are not compatible, like char and byte are not compatible, right? Similarly, byte and boolean are not compatible, which we have established already. So byte is not compatible with boolean, is not compatible with char, and compatible in the sense that whatever value is there in a byte variable cannot be stored in char or boolean. Now let's talk about short. Take a look at the range of byte and take a look at the range of short, and tell me, if we have a byte variable with any value, can that value be stored in a short variable or not? Well, yes, we can. because the lowest value that byte can hold is minus 128, and the maximum value or the highest value that it can hold is 127. Now 127 is way less than the maximum value that short can hold. Similarly, minus 128 is way less than the minimum value that short can hold. So any value that a byte variable can hold can easily be stored in a variable of short type. And that means that byte and short are compatible. And for the same reason, byte is compatible with int and long as well. So let's update this list. Now comes byte and float. So think about it for a moment. We have byte with minus 128 to 127 as the range, and then we have got float with this range. Now, can any value that a byte variable can hold be stored in float? Well, yes. And I'm basing this answer on two reasons. The first one is what we saw with char and float. We saw that if we store a positive integer in float or double, it will get stored, although with .0 at the end, but it can get stored. Now, byte holds numeric values and it holds both positive and negative integers. Double and float also holds numeric values, and they can also store both positive and negative integers, both with and without decimal. So that means float and double gets added to this list. Similarly, if we go for short, what will we see? Well, let's start off with boolean. We know that short and boolean are not compatible. Now what about short and char? Well, short can have both negative and positive integers, but as we know, char only holds positive integers. So we cannot store any value that short can hold in char, which means short and char are not compatible. And the same thing applies to byte, plus the fact that the range of byte is very less than the range of short. So if I take a very large number which fits in short, it will not fit in a byte variable. And for that reason, short is not compatible with byte. But how about int and long? Well, short is compatible with int and long because the range of int and long is way more than the range of short. And both int and long holds both positive and negative integers. So let's put this down. Short is compatible with int, is compatible with long. And we can also say that short will be compatible with double and float, right? So let's put that down here. Now, if we check the same thing for int, we will get to know that int is not compatible with short, int is not compatible with byte, and int is not compatible with char, and int is also not compatible with boolean. Int, however, is compatible with long, float, and double, right? The reasons are the same as what we have discussed so far. So let's put that down over here as well. So int will be compatible with long, float, and double. Now coming back to this list, we are left with float and double. Now take a look at float and its range and the type of data that it holds. Float can store decimal numbers, right? Now tell me, if we have a float variable with a certain value, can we store that value in long as well? For example, if I have 3.14 in a float variable, I cannot store 3.14 in long because long does not support decimal, right? So that means float is not compatible with long, is not compatible with int, short, byte, char, and of course, boolean. Float will only be compatible with double. So let's put this down over here. Now let's come back here and take a look at double. Double is not compatible with any of the remaining 7 data types. Double stores decimal number, both positive and negative. And the range of double is the maximum among all of the data types that we have. So if we take a very large number and we try to store it in float, it will not fit. Although float can store decimals, it can only store decimals up to a certain number, which is way less than the maximum number that double can hold. Now, since double can hold decimals, whatever is there in double will not fit in long, int, short, byte, and char also. And of course, double and boolean are not compatible. That is something we already know. So this gives us this final list. Now, what does this list tell us? This list tells us that if we have a certain data type, which are the other data types it will be compatible with. That means which are those data type pairs where automatic type conversion will take place. And in the discussion that we did over here, it tells us what these 2 points mean. The first point says that the two data types are compatible. So if we take a look at these categories over here, we have got non-numeric, and since it is non-numeric and all of the other categories are numeric, this non-numeric, which is boolean, is not compatible with any one of them. If I take, for example, numeric plus positive integer, since it is numeric and it only holds positive integer, it is not compatible with the remaining two categories that we have. Similarly, if I take, for example, numeric plus decimal is not compatible with any of the categories that we have. And the same thing applies to numeric plus positive plus negative to a certain extent. This numeric plus positive plus negative is in a way compatible with numeric plus decimal because we can store positive and negative integers in data types meant for decimal. What happens is if we store integers, say 10, it will be stored as 10.0. But this numeric plus positive plus negative is not compatible with numeric plus positive and non-numeric. So this tells us the compatibility among the data type pairs that we can have. Now coming to the second point, we see that the destination type is larger than source type. And the discussion that we have over here tells us what this means. For example, if I take source as say int and destination as byte, is byte larger than int? No, right? And when I say larger, what I'm referring to is width and range, of course, because width determines range. Again, I'm not going into the details of why and how width determines range, but I've discussed this in a video which you can access by clicking the card that is appearing on the top right corner of your screen right now. So continuing, the second point was destination type is larger than source type, which means if you choose two data types, the automatic type conversion will take place if the source is smaller than destination or the destination is larger than source. If it is the other way around, that is, the source is larger than destination, automatic type conversion won't take place. So in short, this list tells us in which cases or which of the pairs of data types will have type conversion taking place automatically. So let's mark those pairs in this table with A. So char int, char long, char float, char double. By the way, A represents that automatic type conversion will take place. Continuing, for byte, what do we have? We have short, int, long, float, double. So let's quickly mark these. Similarly, if we take a look here, we will have short making pairs with a few data types, and the same thing applies to int and float. So let me quickly mark these pairs in the table. And I just realized that I did not discuss about long being compatible or not with these data types. So let's take a look at long quickly. Now this is the range of long. Now if I take long variable and I store this number in the long variable, can I store this in int? Well, no, because the maximum number that int can store is less than the maximum number that long can store. And the same logic applies to short, byte, and char. And of course, long cannot be converted to boolean. So long is not compatible with any of these data types. Now, is long compatible with float and double? Yes, because if I take this number and we count the number of digits that we have got a total of 3, 6, 9, 12, 15, 18, and 19 digits. But the maximum number that float can store is 3.4 multiplied with 10 to the power 38, which is way more than the maximum value of long. And because of that, plus the fact that we can store integers in float and double, we can store whatever value is there in long in float or double, which means that long is compatible with float and double. So let's mark it here as well. Now, do you see some pattern over here? Well, if not here, do you see some pattern over here? If we leave char and boolean aside for now and we take into consideration only byte, short, int, long, float, and double, what can we observe? Let's see. If we have short, it is compatible with all the data types that's written before short, that is int, long, float, double. But short is not compatible with the data type that's written after short, which is byte. The same thing holds for long. long is compatible with float and double, but it is not compatible with int, short, and byte. And if you take any data type over here out of these six, you'll find the same pattern. And this is happening because if we write data types in this order, that is double and then float, then long, int, short, and byte, and then we start from byte and go towards double, we can see that the range is increasing as we go up. With Boolean, it is pretty straightforward that Boolean will not be compatible with any of the data types that we have, and char is compatible with some and not compatible with others. Now, all of these pairs are the ones where automatic type conversion will take place. Now, the next question that arises is, what about these pairs? Well, over here, automatic type conversion won't take place, but we can still force type conversion. Let's see how. We can do that with the help of something called type casting. Now, we have just discussed that, say, int cannot be converted to byte. And the example that we had taken was that the int variable will hold this number, 2147483647, which of course is very large for a byte variable. But what if we have only, say, 100 in int? What will happen in that case? Let's go to IntelliJ and find out. So over here, if I get rid of this code first, and then I go for int, say I is equal to 100. Now, if I go for byte, say b is equal to I. Now, what will happen if I put a semicolon? If I put a semicolon, we will get an error. Now, what's exactly happening over here? I is being assigned to b, and I contains 100, and 100 falls within the range that is supported by a byte variable. Then what's the problem? The problem is that although the value of I over here is compatible or falls within the range of value supported by byte, but it is not guaranteed that it will remain the same whole throughout the program. What if over here I go for I is equal to I multiplied with 1000? Now the variable is the same, that is I, and it has got some value which falls within the range of data type that I is associated with, which is int. So if I go for byte b is equal to I over here, what will your reaction be? Your reaction be that this is wrong because I is 100, multiplying that with 1000 makes it 1 lakh, and 1 lakh is of course way greater than the maximum value that a byte variable can store. Because of this reason, automatic type conversion will not take place. But if we as programmers know that the value of I is going to remain 100, or at least is going to remain within the range of byte, we can force the compiler to let the conversion happen. And we can do that this way. What we can do is, over here, before I, we will need to put a pair of parentheses, and inside the parentheses, we will have to say byte. And once we do that, you can see that the error vanished. So what's happening over here is I holds 100 and I is of int type. Earlier, what we were trying to do was byte b is equal to I, which is converting int to byte. And we just saw why that would be problematic. Now, if we can, in a way, assure the compiler will let that conversion happen. And we can assure the compiler by explicitly mentioning the type to which we want to convert it. And we want to convert it to byte. So what we have done is, within a pair of parentheses, we have put byte over here. And this is what typecasting is. So what we do to typecast is, to the value that we have, we append the target type. And we do this something like this. We can say byte, say I. Now, this kind of conversion is also called as narrowing conversion. And the automatic type conversion is also called as widening conversion. So coming back to the table that we have, all of the blank spaces that you see over here represents the pairs where we can go for typecasting. So let's quickly fill this with, say, TC. Now, let me ask you a question. What if I keep the statements as is, but what I do is I change the value that I'm assigning to I? What's going to happen? We have 100, and 100 is within the range of value supported by byte. But what if I make it, say, 10,000 without making any change to other parts of the code? As you can see, there are no errors. So let me quickly put a println statement which will print the value of I, and a println statement which will print the value of b. Now let me revert it back to 100. Let's run the code and check the output. As you can see, we are getting 100 and 100. But what if I make it 10,000 and then run the code? Well, we are getting 10,000 and 16. Now, where is the 16 coming from? To tell you what's happening in short, I holds 10,000 and it can hold 10,000 because 10,000 falls within the range of int. However, if we take a look at this statement, what are we trying to do is we're trying to cast I in byte. And we know that the range of byte is minus 128 to 127. And 10,000 is way beyond the range of byte, which is the reason automatic type conversion won't be supported. But what we told the compiler was to go ahead and still convert it to byte. So what it did was it did some operations and converted 10,000 to a value which will fit in a byte variable. And that is why we're getting 16 over here. Now, I'm not going into the details of what operation is the compiler doing to make 10,000 fit within the range of byte variable, but I'm planning a separate video on this topic. For now, just know that although typecasting makes it possible to convert some of the data type to some other where automatic type conversion is not supported, it comes with its own set of problems. One of which is this. Similarly, if I make it say minus 10,000 and then I run the code, you can see we are getting minus 16. Now, let me take another example and show you the problems that you can face with typecasting. Let's go for float f, and let's say I store 3.14 over here. Now, let's change the I to f over here and the I to f over here as well. And over here, I forgot to add f at the end, which is something we need to specify that this is a float literal. Otherwise, it will take this as a double literal, and we know that we cannot convert double to float, which is why it was throwing error earlier. So now what do we have is a variable f of type float, which contains 3.14. Now what are we doing is we are typecasting it to byte. So if I run the code, what's going to happen? Well, let's find out. The first line of output is 3.14, which is what we expected because we are printing f and f holds 3.14. The second line, however, is 3. What's happening over here is since we are casting a decimal value to an integer type, the decimal component is getting truncated. So that means we will lose everything that is after decimal. If I make it, for example, 30.14, we will get 30 as the output. Now, another question which arises is, what if I make it 300.14? Well, of course, we're going to lose 0.14 and we are left with 300. But 300 is beyond the range of byte, right? So if I run the code, what compiler is going to do is, compiler is going to do some operation which will convert 300 to a value that can fit in the range of byte. So if I run this, you will see we are getting 44. If I use the previous example and I make it, for example, 10,000.14f. If I run the code, you'll see that we will get 16 over here. And if you remember, when we started off with an int variable where we had 10,000 and we casted it to byte, we got 16, right? So what's happening over here is, first of all, 0.14 is getting dropped because we are converting a decimal to integer. Now, the integer that we are left with, which is 10,000, is beyond the range of byte. And that is why some operation is being done on that integer to convert it to a value which falls within the range of byte. And that is how we are getting 16 over here. Now, let me give you another example. Let's say this is float f. And instead of byte now, what do I do is I take double and let's name the variable d and I go for f. Now, of course, we can store float in double, right? And let's replace this with d and run the code and check the output. And this is what we are getting. Do you see the difference? Here we had 10,000.14, but when we converted it to double, whose range is more, the value changed. And the value changed because of how Java stores decimal number and the precision of float versus double. Now we know that float has got precision up to 7 significant digits and double has got precision up to 15 significant digits. And because of the difference in precision and how Java stores decimals internally, the value that we are getting over here is different. Now let me revert this. Let's say I take double over here and let's name the variable d. And then let's also remove f from here. Now, what do I do in line number 4 is I change this to float. Let's say float f is equal to d. Now, first of all, you can see that we're getting an error over here, and that's happening because we know that we cannot convert double to float automatically. We can, but we will have to cast it, right? So once we cast it and once we run the code, we get 10,000.14 in both. But what if I do this? I go for 1, 4, say 6, 4, 1, 2, 8, 9, 7, 6, and then I run the code. The first line of output is 10,000 dot 1464128976, which is what we have put over here. But the second line of output is just 10,000.146. So these are some of the problems associated to typecasting. So typecasting can lead to precision loss, which is what we have seen just now. It can also lead to truncation, that is 3.14 getting converted to 3. Because what we did was we stored 3.14 in a data type which only supports numbers without decimal points. Another problem is overflow or underflow. So over here, overflow is when the number that you store is more than the maximum number the variable of that data type can hold. And underflow is when the number that you store is less than the minimum number that the variable of that data type can hold. So in short, we've got a few problems with typecasting, and they are loss of precision, truncation, overflow, and underflow. Now in this video, I'm not getting into the details of why exactly is this happening, but it has to do with how Java stores integers and floating point numbers. So now, having discussed all of this, let's go back to the definition of type conversion and let's read this one more time. And let's see if we are able to understand all of it or not. So the definition says that type conversion is conversion of a value from one data type to another compatible data type, which means it involves two data types, one source and the other one is destination. And we know that there are a total of 8 data types. So knowing that there are a total of 8 data types, we can get a total of 64 pairs. And these 64 pairs includes those pairs as well, where source and destination are same. But if we take a look at the definition again, it says conversion of a value from one data type to another compatible data type. And taking this into consideration, we get a table, and that table at the end looks like this, where we have some pairs where conversion won't take place because both the data types in the pair are the same. We also have some pairs where the conversion is not possible because they are not compatible. We have some pairs where the conversion takes place automatically, and we have some pairs where we can go for conversion, but we will have to force the conversion. Now, coming back to the definition of type conversion, the second point over here says that it happens during assignment, for which we have seen examples already, and it further says that it happens in expressions as well. So let's talk about this in more detail. For that, let me come to IntelliJ and let me take an example. Let me get rid of all of this over here and let me declare a few different variables of different data types. So in this example, you can see that we have got a few variables of different types. We have got byte, short, int, long, float, double, and char. And over here in line number 13, we're doing some arithmetic operation. Now answer me this. What will be the type of the result that this arithmetic expression will give us? To understand that, you will have to know the type promotion rules. So if you have an expression like this, what's going to happen is all of the byte, short, and char will get promoted to int. So this short will get promoted to int, this byte will get promoted to int, and this char will get promoted to int. So ultimately, it will then be multiplication of float with an int. The value will remain the same. It's just that the type will be promoted. Similarly, this will be a double number getting divided by an int. And lastly, here we will have long divided by an int plus an int. Next, what's going to happen is if the expression has a long, the entire expression will get promoted to long, which means the result of this will be a long value. And the next one would be if we have float, the entire expression will get promoted to float, which is what is going to happen here. So this will be float. And if we have double, the entire expression will get promoted to double. So what's going to happen here is this will be double. So now we have got float, double, and long. And let's put the operators as well. So what's going to happen here is Following the same rules, what's going to happen is if we have byte, short, or char, it gets promoted to int. But we have float, double, and long. And if we check the list of rules that we have, if there's a double, the entire value gets converted to double, right? Whatever value this expression gives will be of double type. So coming back to IntelliJ, if I say double say result is equal to, there will be no errors. But if I use any other data type, if I use say float, we will get an error. The same thing will happen on using long, int, short, byte, and char, and of course, boolean. So double is the correct answer. Now we're almost at the end, but before we wrap up, let me ask you one question. Let's take this example. We've got a variable b of type byte, which holds 50. Now what's going to happen if I say b is equal to b multiplied by 2? So let's come to IntelliJ and see what's going to happen. We have byte b is equal to 50, and in the next line we're going for b is equal to b multiplied by 2. Now I'm not putting a semicolon yet, but tell me what's going to happen if I put a semicolon. So if I put a semicolon, you can see that it is giving an error. So what's happening over here is we have b multiplied by 2 and b is 50. So 50 multiplied by 2 is 100. Now we are storing 100 back in b. But recall the type promotion rules that we just discussed. If we have an expression where there's a byte, that byte will get promoted to int, right? So b, which was byte originally, got promoted to int. Now the multiplication of b and 2 will give us int. But what we are doing is we are storing it in b, which is a byte variable. And that is why we're getting this error. And if I hover on this, you will see it says required type byte, but we have provided int, which means since b is a variable of byte type, it should get a byte value. But what we have done is we have provided int value. So this brings us to the end of the video. Summarizing, we talked about type conversion, and more explicitly, we talked about automatic type conversion and typecasting. Then we also discussed the problems associated to typecasting. And lastly, we talked about the type promotion rules. So I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.